Okay. So today we will discuss problems related to partial differentiation. So we have the problem if u is equal to function of y minus z, z minus x minus y. So then prove that del u upon del x plus del u upon del y plus del u upon del z is equal to 0. Okay. So here we have three functions that we consider as. So while doing the solution of this problem, so we assume, let us assume that x1 is equal to y minus z, x2 is equal to z minus x, x3 is equal to x minus y. So here we write down as u is now function of x1, x2, x3. So u is the function of x1, x2, x3, and we write down as x1 comma x2 and x3 be the function of x, y, z. Okay. So then first we calculate del u upon del x. So del u upon del x. So now del u upon del x. U is the function of x1, x2, x3, and x1, x2, x3 is the function of x, y, z. So when calculating del u upon del x, so this we can write down as del u upon del x1 into del x1 upon del x plus del u upon del x2 into del x2 upon del x plus del u upon del x3 into del x3 upon del x. So here we write down as del u upon del x1 into del x1 upon del x. So x1, when we differentiate x1 with respect to x, so there is no term of x in x1, so differentiation will be 0 because y and z we treat as a constant, plus del u upon del x2 into del x2 upon del x. So del x2 upon del x. So the derivative of x2 with respect to x is -1 plus del u upon del x3 into del x3 upon del x. So derivative of x is 1 and y is 0 because we treat y as a constant. So we write down this as minus del u upon del x2 plus del u upon del x3. So this is the value of del u upon del x. So now we give as equation number 1. Similarly, we calculate del u upon del y. So we write down as del u upon del x1 into del x1 upon del y plus del u upon del x2 into del x2 upon del y plus del u upon del x3 into del x3 upon del y. So this equal to, so del u upon del x1 into del x1 upon del y. So x1 equal to y minus x. So when we differentiate partially with respect to y, so this gives us 1 minus 0. So we write down this as 1 minus 0 plus del u upon del x2 into del x2 upon del y. So x2 upon y, there is no term of y in x2. So derivative will be 0 plus del u upon del x3 into del x3 upon del y. So del x3 upon del y, this gives us -1. Okay. So we write down this as del u upon del y is equal to del u upon del x1 minus del u upon del x3. So this is our equation number 2. Now, Again, we calculate the del u upon del z. So this equal to del u upon del x1 into del x1 upon del z plus del u upon del x2 into del x2 upon del z plus del u upon del x3 into del x3 upon del z. So this we can write down as del u upon del x1 into del x1 upon del z. So del x1 upon del z, so the differentiation will be 0 minus 1. So we write down that x0 minus 1 plus del u upon del x2 into del x2 upon del z. So del x2 upon z, del z equal to 1 minus 0 plus del u upon del x3 or del x3 upon del z. So there is no term of z in x3. So derivative will be 0. So derivative will be 0. So we write down this as del u upon del z is equal to del u upon del x1 plus del u upon del x2. So this is our equation number 3. Now we see that our result. So our result is del u upon del x plus del u upon del y plus del u upon del z equal to 0. So now we add equation 1, 2 and 3. So adding equation 1, 2 and 3. So we get del u upon del x plus del u upon del y plus del u upon del z is equal to. So first RHS side of first equation is minus del u upon del x2 minus del u upon del x2 plus del u upon del x3 plus del u upon del x3 plus del u upon del x1 minus del u upon del x3 minus del u upon del x1 plus del u upon del x2. So del u upon del x2 to del u upon del x2 cancel. Del u upon del x3 to del u upon del x3 cancel. Del u upon del x1 to del u upon del x1 is equal to 0. So this is the proof of the question. So we take another question related to partial differentiation, means total differential. So another question is given in this form. If x is equal to xi cos alpha minus eta sin alpha and y is equal to xi sin alpha plus eta cos alpha, so that del square u upon del x square plus del square u upon del y square is equal to del square u upon del xi square plus del square u upon del eta square. Okay, so we solve this question. So here in LHS side, we see that u is the function of xy. Okay, so from LHS, we see that u is the function of xy because we are differentiating u with respect to x and with respect to y. So u is the function of xy and x is the function of, so x is given as xi cos alpha minus eta sin alpha and y is given as xi sin alpha plus eta cos alpha. So this says that x is the function of xi and eta, and this shows that y is the function of xi and eta. So y is also function of xi and eta. Now we are going to differentiate partially u with respect to xi and eta. Okay, so now when we write down a del u upon del xi, so del u upon del xi, this can be written as u is the function of x, so del u upon del x into x is the function of xi, so del x upon del xi plus del u upon del y into del y upon del xi. So here we see that alpha treat as a constant. So alpha treat as a constant. So alpha work as a constant. So we write that. Okay. So here we write down del u upon del x into del x upon del xi. So del x upon del xi. So differentiation of x with respect to xi gives us cos alpha. So when we are going to differentiate partially with respect to xi, so eta we treat as a constant. So eta we treat as a constant. So plus del u upon del y and del y upon del xi. So del y upon del xi gives us sin alpha. So gives us sin alpha. So this we can write down as cos alpha into del u upon del x plus sin alpha del u upon del y. So this is equal to del u upon del xi. Now we use one rule here. So that rule will be the dependent variable here is u, and similarly the dependent variable is u. So this we can write down as del upon del xi is equal to cos alpha into del upon del x, okay, plus sin alpha del upon del y. So here we eliminate dependent variables from both sides. So this gives us this condition. Okay. Now, when we obtain a second derivative, this second derivative we write down as del square u upon del xi square. So this we can write down as del upon del xi into del u upon del xi. So this equal to, so del upon del xi, here we use equation 1 and 2. So for del upon del xi, we can write down as cos alpha into del upon del x plus sin alpha del upon del y into del u upon del xi. So the value of del u upon del xi is cos alpha del u upon del x plus sin alpha del u upon del y. Okay, so we operate this function to del u upon del x and del u upon del y. So this we can write down as cos alpha into del upon del x. So we are going to derivative of what? So derivative of this cos alpha del u upon del x plus sin alpha del u upon del y plus sin alpha del upon del y into this. So cos alpha del u upon del x plus sin alpha del u upon del y. So this equal to, so we write down as cos alpha. Now differentiation, that means cos alpha, this cos alpha treat as a constant. So we write down this cos alpha and differentiation of this del u upon del x. So differentiation of this del u upon del x is del square u upon del x square plus sin alpha, and differentiation of del u upon del y is del square u upon del x del y plus sin alpha. We similarly we do the same. So del cos alpha del square u, this can be written del square u upon del y del x plus sin alpha del square u upon del y square. Okay, so we write down this as cos square alpha del square u upon del x square plus sin alpha cos alpha del square u upon del x del y plus sin alpha cos alpha, or del square u upon del x del y is equal to del square u upon del y del x. So we also here write as del x del y, or plus sin square alpha del square u upon del y square. So we add these two terms. So we write down as cos square alpha del square u upon del x square plus 2 sin alpha cos alpha del square u upon del x del y plus sin square alpha del square u upon del y square. So this is the value of del square u upon del xi square. So this is our equation number 3. Okay. So similar process we do for the del u upon del eta. So now we obtain del u upon del eta. So del u upon del eta. So means we write down a del u upon del x into del x upon del eta plus del u upon del y into del y upon del eta. So here we write down as del u upon del x into del x upon del eta. So del x upon del eta. So when we differentiate x with respect to eta gives us minus sin alpha. Del x upon del eta is minus sin alpha. So this gives us minus sin alpha plus del u upon del y into del y upon del eta. So del y upon del eta equal to cos alpha. So this gives us cos alpha. So this gives us cos alpha. So similarly, we write down this as sin alpha into del u upon del x plus cos alpha del u upon del y. So when we understand the first part, that means del u upon del xi. So similarly, we do the same for the this part. So this is the equation number 4. And when we eliminate the dependent variable from both sides, so we write down as del upon del eta is equal to sin alpha del upon del x plus cos alpha del upon del y. So this is equation number 5. Okay. So now we calculate del square u upon del eta square. So del square upon del eta square. So this can be written as del upon del eta and del u upon del eta. So this equal to del upon del eta minus sin alpha del upon del x plus cos alpha del upon del y into del u upon del eta. So minus sin alpha del u upon del x plus cos alpha del u upon del y. So this equal to minus sin alpha del upon del x, and we operate this bracket. That means minus sin alpha del u upon del x plus cos alpha del u upon del y plus cos alpha del upon del y into minus sin alpha del u upon del x plus cos alpha del u upon del y. So this equal to minus sin alpha, and we differentiate this as, so first this is constant and differentiation of del u upon del x is del square u upon del x square plus cos alpha into del square u upon del x del y plus cos alpha, or here is minus sin alpha del square u upon del y del x plus cos alpha del square u upon del y square. So now we write down this as sin square alpha minus minus plus del square u upon del x square plus this is minus, so we write down minus sin alpha into cos alpha del square u upon del x del y minus sin alpha into cos alpha del square u upon del y del x can be written as del square u upon del x del y, or plus cos square alpha del square u upon del y square. So here we write down this as sin square alpha del square u upon del x square minus 2 sin alpha into cos alpha del square u upon del x del y plus cos square alpha del square u upon del y square. So this value is equal to the del square u upon del eta square. So this is the equation number 6. Okay, so we see that the equation number 3 and 6. Now we add 3 and 6. So adding equation 3 and 6. So when we add equation 3 and 6, so we get del square u del square u upon del xi square plus del square u upon del eta square is equal to. So the first term of equation 3 is cos square alpha into del square u upon del x square. So we write down cos square alpha del square u upon del x square plus 2 sin alpha cos alpha del square u upon del x del y, and the third term is sin square alpha del square u upon del y square. So third term sin square alpha del square u upon del y square plus sin square alpha del square u upon del x square minus 2 sin alpha cos alpha del square u upon del x del y, or plus cos square alpha del square u upon del y square. So this term will cancel with this term, and we take del square u upon del x square common from these two terms. So we see that when we take del square u upon del x square is common, so cos square alpha plus sin square alpha. Okay, so similarly we take del square u upon del y square from these two terms. So we see that del square u upon del y square, so sin square alpha plus cos square alpha. Okay, so we know that sin square alpha plus cos square alpha equal to 1. So this gives us del square u upon del x square plus del square u upon del y square. So this value is equal to del square u upon del xi square plus del square u upon del eta square. So this is our proof. Okay.